Hello everyone. Today we would be dis- Today we would be discussing Codeforces round 927. Like before we get started, can anyone confirm if audio and video everything is fine? Okay. Thanks Nipun. Thanks Akash. So let's get started. I was able to solve only for six problem, and on the last problem I had some ideas, but like it looks like I am missing on some cases over here. So like I will go through all the problems and let's see how it goes. So let's start with the first problem, thorns and coins. During the journey through computer universes, you stumbled upon a very interesting world. It is a path with n consecutive cells, each which can either be empty, contain thorns, or a coin. In one move, you can move one or two cells along the path, provided that the destination cell does not contain thorns and belongs to the path. If you move to a cell with a coin, you pick it up. You want to collect as many coins as possible. Find the maximum number of coins you can collect in the discovered world if you start in the leftmost cell of the path. The first line, like input given, a string is given, like here in the string it says dot denotes an empty cell, at the rate sign denotes a cell with a coin, and star denotes thorns, and it is guaranteed that the first cell is empty. So, like, to summarize the problem statement, look at examples over here. Okay, so first problem says you are given a string which denotes some consecutive cell, and like at the rate sign denotes there is a coin, and star denotes like there won't be able to coin. Let's look at the samples. Like this is the first sample, and here like what you can essentially do is like this is your starting cell. You move one cell right, you would be here, and now you pick this coin up over here. Now you move one more on the right side, like there is one more coin, you pick it up. Now like this is the point like which is blocked over here, so we cannot jump over here. And in each step we can either go one cell right or two cells right. So here next what we will do is we will directly jump over here, and since we have reached a point which also has a coin again, like then we can pick this cell again over here. Now let's move one more cell to the right, although we can jump one or two, but we have to pick as many coins as we can. Now if we move one more cell, like this would be our original position, this would be our position. And now if we try to move the next cell, it's blocked. The two cells after it is also blocked, so like we can no longer get to anywhere on the right side. Like this is the last stop we will be able to reach. And so far we have collected 3 coins, so like that's why the answer in this case was 3. And in the next example, like this is our starting cell, like then we can move to the next cell, pick this coin, then move to the next cell, pick this coin, then move to the next cell, pick this coin, then move to the next cell, pick this coin. So the answer would be 4 overall. And now let's look at next example again. So like again, this is our starting position. We move one cell right, pick this coin. We want move one more cell right, pick this coin. We move one more cell right, nothing is here, but we can move here. Then one more cell right, nothing is here, but we can move right. Then one more cell right, we pick one coin. And now if we try to jump one, this is blocked. We try to jump two, this is blocked. So like this would be the last cell we can go. And the answer, that's why over here was 3. So if you notice a pattern over here, like whenever you find two consecutive block cell, you can no longer move on the right path. But if there is only one block path, you can simply ignore it and jump over it. Here when you came with two consecutive cells, like that path is blocked again. So the idea is, like, we start with the first index. Or like 0, let's call it 0 if we are using 0 based indexing. Now we keep moving one cell to the right. If the right cell is blocked, then we try to move two cell to the next part. If that part is also blocked, then we have to break over here, like we can no longer move to the right path. Otherwise what we can say is, like, we can move to the next cell. We can check if it's contain a coin, we add answer plus plus. If it does not contain a coin, we do not increment answer, but we still move to the right. And like this was essentially the idea for this problem. Like I will jump on to my code for this one. Like if you want to check about your rating, like you can look at some of the rating predictors. We start with current position as 0, as long as we have not crossed the complete string. If current position is blocked, if current position, a next cell exists, and next cell is also blocked, in that case we should simply break, like we can no longer jump from this part. Otherwise we can jump the next cell to move two cell to the right. If current cell contains a coin, add it to your answer count and move one cell to the right. And like this was the idea for this problem. Like why is it 2? We should jump two cells and like let's move this. Like if the current cell contains a coin, add this to our counter. Okay, 1 second. Okay, not really sure like what I am missing. Zero, 1, 2. Okay, like if we are in current position and the next cell is blocked, then we should jump two positions. Sorry about this. So like this is the idea for this problem. Like the idea is like we are on current position. If current position contains a coin, add it to your answer. And if the next cell is blocked, then you try to see like if there are two cells and that if you try to make a jump of two is if that's also blocked, then you essentially cannot do anything over here. Otherwise, you can make a jump of two and continue. And if the next cell is not blocked, then you simply you jump one more point to it. And like this was essentially the idea. Like any questions on this one before I move to the next problem? Okay, so I will move to the next problem. It says Chanya's calendar. Chanya tribe believes that there are n signs of apocalypse. Over time, it has been found that the ith sign occurs in AI interval, that is, in the years AI 2 into AI 3 into AI, and so on. According to the legend, for apocalypse to happen, the signs must occur sequentially. That is, they wait for the first sign to occur, then strictly after it, the second sign must occur, and so on. That is, if the ith sign occurs in the year X, the tribe starts waiting for the occurrence of I plus 1 sign starting from the year X plus 1. In which year will the nth sign occur and the apocalypse will happen? And like, let's look at start with samples again. Like, let's call it a doomsday. Like, I found like pronunciation a bit difficult. So like what it says is like we are given some an array A of integers. Let's take with the first sample 3, 4, 2, 5, 9, 18. So it says like in the first example, it says like there are 6 signs of doomsday. First sign appears on day 3, 6, 9, 12, and so on. The second sign of doomsday appear on all the multiples of 2, 2, 4, 6, 8, 10, so on. Third sign of doomsday appears on 4, 8, 12, 16, and so on. Fourth sign of doomsday appear on 5, 10, 15, 20, and so on. Fifth sign of doomsday appears on 9, 18, 27, and so on. And the last 6 signs of doomsday appears on multiples of 18, so on. And like when like the tribe has seen like all the n signs one after the others, then on the last sign they will say like the doomsday has came in. So like they start looking at the signs from the first day. Like after like when they start looking like the first time they will see the first sign, it would be on day 3. Now once they have seen the first sign, like they should look at the next sign which appears after day 3. So the next time the second sign appears after day 3 is on day 4. So on day 4 they will also see the second sign of the doomsday. And like once they've seen the second sign of doomsday, like they should wait for the third sign of the doomsday which will appear after day 4. And if you look at over here, like the next sign after day 4 when the third sign appears is on day 8. So on day 8 like they will see like the third sign of the doomsday. Now when they have seen the third signs of doomsday, like they should wait for the fourth sign of the doomsday. And like the first time like fourth sign appears after day 8 on doomsday is on day 10. And now once they have seen the fourth sign of the doomsday, they should wait for the next fifth sign which will appear after 10th day. And next time the next sign appears is on day 18. And after they have seen the fifth sign, they should wait for the next time when the last sign, sixth sign would appear. And if after 18, the next time when a sign next sign appears is on day 16. And like this would be the day that when they have seen all the doomsday, like all the signs so far. So this would be the day for our doomsday, and we should print this as an answer. And like this was essentially like what the problem was asking. Like I will take, like I believe, like if I go through all the examples, then like the problem, you would also know how to solve it. So like let me take the second example again. It says 1 2 3 4 5. So like on the first sign, like the day, like first sign will appear every day, second sign appears every alternative day, third sign appears every third day, fourth sign appears like every fourth day, and the fifth sign appears every next day. So like when you start observing from day one, like the first time you will see sign one is on day one, and now you try to find like when would you will you see the second sign which is happens, which comes after day one, and this is essentially day two only. Now like after you have seen the second sign on day two, you wait like when will you see the third sign after second day, and this is essentially day three. So on like after like the number which is greater than for the next sign would be 4, and after 4 the number would be 5, and like on day 5 you will have seen all the signs so far, so the answer here is 5. Secondly, in the next example, like all the signs appear every day. Like a sign may appear multiple times, but like we only care like when the first time sign 1 would be see on day 1, and the after day 1 the second sign will appear on day 2 again, and after second day like the third sign will appear on day 3. Like although the sign is appearing on the same day, but you cannot check two signs for the same day, because the problem statement says like you should start like after you have seen the ith sign on year x, you should look out for the I plus 1 sign starting from x plus 1th year. And essentially this would be our answer over here. Similarly, we can work out on the last sample again. 50, 30, 711, 200, 503, 1006. So like the if you start from day 1, like the first time you will see first sign would be on day 50, and then after day 50 if you start looking from day 51, the next time a multiple of 30 will appear would be on day 60. So the second sign would be seen on day 60, and starting from day 61 the next time you will see sign multiple of 711 is 711 only. So like the third sign would be seen on day 711, and then after 7 starting from 712 to the next multiple of 200 is 800. So you will see like the next sign on day 800, and starting from 801 the next multiple of 501 would be 1006. The next time you will see like fifth sign would be on day 1006, and starting from day 1007 the next time a multiple of 1006 is 2012. So the last like doomsday is in the year 2012, and like by now you would have figured out like you maintain like when you see an I sign, and for the I plus 1 sign you should look at the next multiple of that year which is greater than the current multiple. And once you have figured out like there are many ways to do it, like you can also try to binary search to find the next multiple, or what I did was I started from day 0. Like I have seen like how many multiples of the current sign have happened so far. Like for example, if I want to look at the next multiple of 30, what I see is like how many times I have seen the day which has already been gone. So like 50 divided by 3, if I take integer division 1. So like I have to skip one multiple so far, and I can take the second multiple. Similarly for 711, like for 200, I divide 711 by 200, and this will say like I have already missed out 3 signs so far, and I should look at the next multiple over here, which would be 800. And like this is essentially the idea. I take the next multiple when the next doomsday will appear, and then I calculate like how many multiples I have to skip so far. and I add +1 to it and multiply that by x. Like that would be the next day when the next doom sign would appear. And like this was essentially the question. And like any questions on this one so far? Like the problem is like you cannot iterate on the doomsday and check if a multiple is there or not. Because if you see like the multiple is up to 1 is 6 and like there is no limit on sum of n over here. So like if you keep choosing like let's say 1 is 6 next time, all AIs are 1 is 6, then the first time you will see doomsday would be on 1 8 would be the final day, and there are 1,000 test cases, so like you will get essentially a TLE. I will move to the next problem now. So it says LR reminders. You are given an array of length n and a positive integer m, a string of commands of length n. Each command is either a character L or R. Process all the n commands in the order they are written in the string. Processing a command is done as follows. Output the remainder of product of all the numbers in array when divided by m. It asks for the remainder. If the command is L, remove the leftmost cell of the array, and if the command is R, remove the rightmost cell from the array. Note that after each move, the length of array decreases by 1, and after processing all the commands, it will be empty. Write a program that will compute all the commands in the order they are written in the string from left to right. So like let's go through samples once again. Like the first sample is like we have to print modulo 6. The values are 3142 and the commands are L R R L. So like before the first command, like the product of before the first command our array would be like 3141 and the product of all of this is 12 and 12 modulo 6 is 0. So we have output 0 over here. And now we have one left command. So after like the product is 24 over here, sorry. And 24 modulo 6 is 0. Now if you look at it, like now you have to remove the left cell over here. And the remaining array would be 142. And the product of these numbers is 8, like 4 into 2, 8. And 8 modulo 6 is 2. So we have to now output 2 again. And now we have to remove one cell from the right. The remaining numbers are 1 and 4. Their product is 4. 4 modulo 6 is 4. So we have output 4 over here. And now we have to remove one more number from the right. The remaining number is only 1. 1 modulo 6 is 1. So we output 1 over here. And at last we remove it and the array is empty. Like the problem over here is like the problem here is like if you say like our product is A1, A2, A3, A4, A5, A6 and AN, let's say. Then if you know like product modulo M, like now we have to remove let's say A1 from the array and again find A2 to AN modulo M. The problem here is like we cannot directly divide this product by A to get an answer for it. Like let's say like this is the result we are printing. Then we cannot directly divide A over here. Like to take an example over here. Like your product was 24 and when you remove 3 from it you got 8. But if you try to divide 0 by 3 you would have got 0 again, and 0 is not equal to 2 over here. So like that's the problem. Like for example 3142, their product is 24. 24 modulo 6 is 0, but 1424 like product is 8. 8 modulo 6 is 2, and you cannot directly divide 0 by 3 like it will again give you 0, but our answer is 2 over here. And like one more problem here was like it's nowhere written that m is a prime number, something like that. Had it been a prime number, like there were some ways to do these things faster. So like the one way we can do is like if you have no two numbers, then if and let's say C is A mod M and D is B mod M, then we know that A multiplied by B mod M would mod M will be C multiplied by D mod M. This works. But if you know like A divided by B is not equal to C divided by D mod M. So like if we try to divide the answer and try to find it, like there we would be in difficult problem. Like we don't know like what would be the new remainder when we divide it. But if we start with let's say an empty array and then we keep adding new values based on left and right and find all the answer in the reverse, then we would be able to use this identity to find the product. Like for in our original example of 3142, let's start with the empty array first, then add 1 to it. Then after 1, like then add 4 to it. After 4, then add 142 to it. And after 14, like 142, add 3142. Now if you see like numbers over here the product is empty, let's just assume 1. Then when you multiply 1 by 1, like your product is 1 mod 6, which is 1. Like now you have 4, like 1 into 4, like you can just multiply this 1 by this new number which you have added, which would be 4 mod 6, which is again 4. Now when you added 2, like you multiply 4 by 2, which is 8 mod 6, which is again 2. And now when you have added 3 over here, you multiply 2 into 3 and take mod, which would be 0. So you have got all the answers over here. And the problem is like we cannot take complete product in the integer as well, like because each number is up to 1e4 and like there are 2 to the power 5 numbers. So in the worst case our final product can be 10 to the power 4 into 2005, and it will exit long int limit. And like this was the main idea. Okay, instead of dividing it, you start with empty array and keep adding left and right based on the value of L and R. And once you have found like and multiplying new number and getting modulo again is an easier job. And this was my idea. Like first I start with left pointer, left cell as 0 and right cell as 1. Whenever I see a x like left command, I increase this left pointer by 1. Whenever I see an R command, I decrease this R pointer by 1. After the end of this loop, my array would be empty, where the left pointer would be 1 more than the right pointer. And now I start with product equal to 1. I iterate on the string in the reverse. I look at the command. If I am processing the commands in reverse, then whenever the left command appears, I add something on the left side. If the right command appears, I add something on the right side. So like if the original command was to move left, when I was deleting it, now instead of deleting, I am adding a new value over here. So I moved my left pointer a bit on the left side and I multiply product with the current value and take its as mod. Or if the command was to move right side, I move my right command to the point right side, and like now you can take product with the new value you have added, and you got the final product. Now you have added like the remaining cell over there and you keep completing over there. And like this was essentially the idea. And like yeah, some people correctly mentioned out like they can also use stack over here. Stack, yes, you can also use stack. Like you first insert all the elements in the stack and then you pop them to find like the answers in the reverse. Like this would reduce the hassle of using left right pointers as well. And yeah, like some people have also mentioned that they use segmentary. Like segmentary also works because when you combine two nodes, like you multiply both of them and take mod again. Like if you look at your combined method on the segmentary, like there is no division over there. So like in the for the segmentary, you can also maintain this left and right pointers, and like then you can use like a range product, like product to find left to right, and you will get the answer as well. Like DQ, like you can also use DQ, but DQ is essentially more powerful than a stack. So if you can do something from stack, you can also do it from DQ as well. And like these were like some different solutions for this problem. Like the way I did was like I believe the stack solution is more clean than what I did over here. And like segmentary, I would say is a bit overkill, but that also does the job. And like this was the third problem. Like any questions on this one before I move to the next problem? Yeah, like at least I believe if I remove template, my code for D was not more than a lot of line. So like the problem D says card game. Two players are playing an online card game. The game is played using a 32 card deck. Like it's different from a standard 52 card deck. Each card has a suit and a rank. There are four suits: clubs, diamonds, hearts, and spade. We encode them with characters C, D, H, S, respectively. And there are eight ranks in increasing order: 2, 3, 4, 5, 6, 7, 8, 9. Each card is denoted by two letters, its rank and its suit. For example, the 8 of hearts is denoted as 8H. At the beginning of the game, one suit is chosen as a trump suit. In each round, players make move like this. The first player plays one of his card on the table, then the second player must beat this card with one of their cards. And after that, both the cards are discarded piles. A card can beat another card if both the cards have the same suit and the first card has a higher rank than the second. For example, 8S can beat 4S, like because their suit is same and like the rank of 8 is higher than 4. Additionally, a trump card can beat any non-trump card regardless of the rank of suit. For example, if the trump suit is clubs, then 3C can beat 9D. Note that trump card can be beaten only by a trump card of higher rank. There are n rounds played in the game, so the discarded pile now has 2 n cards. You have to reconstruct the round played in the game, but the cards in the discarded pile are shuffled. Find any possible sequence of n moves that might have been played in the game. So like some test cases, some number of cases, and then we have 2 n cards. If it's impossible to find a pairing over here, then you should print impossible. Otherwise, you can print any of the existing solution. You are also given the trump suit. So like to summarize problem once. Like in the first problem, it says like S is the trump suit, and like 3C, 9S, 4C, 6D, 3S, 7S. So like because S is the trump suit, 3S and 7, 3S, 7S, and 9S can beat any of these cards. So one possible way to do is like you choose pairing such that the second player always get a trump card and the other player can get anything. Like the other way, like over here would be like, and if we look at the output over here, output is 3C, 4C, 6D, 9S, 3S, 7S. So in this case, both of them have same rank. So like higher rank wins, and this is valid. in this case, like let's just make it 3C. Like this is also a valid output. Like 6D, 3S can beat 6D because S is our trump suit. So like any trump suit can beat any of the non-trump suit. So this would be valid. And in this case, both of them are trump suit. So like this one should have higher rank, and because 9 is higher than 7, like this is also valid. So like the idea I had to solve this problem was like let's rank all the suits of the same rank we have in an array over here, something like that. For example, 3C, 4C, 5C. Let's say like there are three suits. S is our trump card. And the other was like let's say 2D, 7D, and like 4H, 5H, 7H, 8H. And like let's say S is the trump suit, we also have 3S, 4S, 7S. So like these are the trump cards. So like the way to solve this problem is you try to create as many pairs from the same rank over here. So like you first make a pair from 3S, 4S, and now like this is gone. But 5C remains, and like there is no suit of the same type. So in that case, like you pair 5C with one of the trump cards. So like 3C, 4C, this is gone. Now because 5C is remaining, you pair 5C with one of the trump card. You can take any trump card, that works. Now you have 2D, 7D, like you can pair this, like if you have sort this in increasing order, then you can pair 2D with 7D and remove them from the table. Now you look at like all the edge cards, like once you sort them based on their rank, you can again pair over here, like 4H, 5H can be paired, 7H, 8H can be paired. Had there been one more card over here, like we would have used trump card to make a pair for it. And now only trump cards remain. Then you can also sort them in increasing order and pair them. So 4H and 7H can be paired. 4S and 7S can be paired. Like this was essentially the idea. So what we can do is like we can maintain a map or something like that where we add all the cards apart from the trump card, and then we sort them. We make pair of into two where it's because it's in increasing order you can take them. And if there are odd numbers of card, you pick one trump, you pull out one trump card to defeat that card. And like that was the main problem. And like this was the idea. Mm-hmm. So like I take the number of cards as input and the trump card, like because this S is of only one character, like I mark trump card as a character C. Now I am maintaining a map of like first character denotes the suit and all the cards I have in this suit, and I maintain a separate vector for the trump cards. I read everything. I read the type of card. If the type of card is trump card, I push it into the trump card set. Otherwise I put it into the map based on its rank. Now this game denotes like all the pairs which I would be outputting at the end. And this FL denotes like I have found a valid pairing. The problem happens when let's say you have three ranks of one card and there is no trump card for the last card over here. Like three cards of one type and one card of the other type. Now you definitely need two trump cards. So I iterate on the vectors. Like V is the vector set, I sort all of them. If the number of cards are odd and the trump card set is empty, I say that the answer is impossible, break over here. Otherwise, I take the last card because it's odd. I take the last card and I pair it with one of the trump card. And I remove both of them from here and I decrement the size of my current vector again. Now, like when I am here, like the number of cards for the current suit is even. So I make them, after I have sorted them over here, like I make them into the pairs of 2 2 and add it to the game and clear the set. And at last, if my answer is still valid and there are some trump cards remaining, I again take M because the total size was 2M. Here you can check like the condition will always like the number of remaining trump cards will always be 1. So I also pair them into the sorted order of 2 to 1. Like I believe I have sorted the trump card. Yes, I have sorted the trump card. And if I did not found an answer, print impossible. Otherwise, print all the sets I had. And like this was the idea for this problem. Any questions on this one before we move to the next problem? And like someone did ask a very good question in the chat, like why my submission got accepted for the problem A. Like here I should check it's N or not. You are right. Okay, the problem with the string is like string contains last character as a null character. So if the string length is 5, then actually there are 6 characters denoted over here where the 6th character is null character. So that's why I escaped like null pointer exception over here. Had it been an array, I would have got the null pointer exception. But you were right, like I should have made this check over here. So like this was problem D. And like any ideas before we move to the problem E? Okay, like problem E was a bit tricky one because like it had like numbers up to range 4e5. So like I will move to problem E then. Final countdown. You are in nuclear laboratory that is about to explode and destroy the earth. You must save the earth before the final countdown reaches 0. The countdown consists of n mechanical indicators, each showing one decimal digit. You notice that when countdown changes its state from x to x minus 1, it does not happen in one move. Instead, each move of a single digit takes one digit. For example, if the countdown shows 42, then it will change to 41 in 1 second because only one digit was changed, like if you compare these two. And if the countdown shows 2300, when it will change to 2299 in 3 seconds because 3 digits have changed, 300 and 299. And it have been asked how much time it is left before the countdown reaches 0. So like let's look at some examples over here. Like dealing with big integer was a bit of pain over here. So like it says like for example if you start countdown from let's say 225, then in the next move you go to 224, so on, then you go to 222, then like 1 second it's take because only the last digit is changing so far. And now when you go to the next digit it becomes 219. Here it will take 2 seconds because 2 digits have changed. And then some more time takes and the countdown reaches 200. And once you move from 200 to further, like the next number is 199. This time all the 3 digits have changed. So to reach from 200 to 199 it takes 300 seconds. And now you keep moving further. Like let's say you have reached 190. Then after 190, if you want to reach 189, the time taken would be 2 because 2 digits have changed now. And if we keep moving it, at last we will reach 1 and then 1 will reach 0. And like we have been asked to find the total time taken in all of these counters. Like let's first forget like the integers are really big. Like how do you calculate the answer? Like one way is like you start from iterating, like from the last number you subtract 1 from it, and then you compare the number of digits changed over there and you keep continuing. One more smart thing you can do is like let's say if you start from 225, on every move the last digit changes. So you directly add 225 to the answer. Now let's forget the last digit. Let's see how many times like the second last digit changes. So if you start from 2 to, like I claim like the second last digit changes 22 times. Like the number is of form this, then the number becomes of form this, then the number becomes of form this, and then the number becomes of this form. So by looking at the number, like if we divide the whole number by 10, we can directly say like the second last number changes 20 times, 2 times. Now if we look at like the third last digit from over here, like the initially the number would be of from this, then the number of becomes of this form, and the number becomes of this form. So like this digit will change 2 times. So overall answer in this case would be 249. So like this was the main idea. Like instead of, because all the digits are changing, instead of counting like after every move what changes, you can count for like every digit how many times that number will change, and then you can take sum of all of them. Like this is equivalent to like every move counting how many of them have changed and taking total sum. Instead of, you do the reverse, you check for each digit how many times it changes, and like this is the idea. Now if you verify in the samples over here, like 42, the last digit changes 42 times, the second last digit changes 4 times, hence the result is 46. Now when you look at 1 2 3 4 5, last digit changes 1 2, okay I forgot. If you take 1 2 3 4 5, the last digit changes 1 2 3 4 5 times, the second last digit changes 1 2 3 4 times, third last digit changes 123 times, fourth last changes 12 times, and the fifth last changes 1 times. And when you take the sum of all of these, this is the sum, and like this is also your answer. So now what you know is like you have been given a big integer. Let's call its digits, like start from the last digit as d1. This is a big number and you have to do some multiples over here. So like if we try to maintain like all the bits, like we can also start with 0th place if you want. Like let's just keep it 1's place because I have been using 1 base index. Then you know like this would be the times first digit changes. This would be the number of times second digit changes. This would be the time third digit changes. This would be the time fourth digit changes, and this would be the time fifth digit changes. And if you see, like it's essentially a suffix sums. Like fifth place sum is only d5s. Fourth place the sum is d4 d5. Third place the sum is d3 d4 d5. Second place the sum is d2 d3 d4 d5, and the first place the sum is d2 d3 d4 d5 d6. So you can take all the sums over here, and like if I work out with my example of 1 2 3 4 5, this sum is 15, this sum is 10, this sum is 6, this sum is 3, this sum is 1. Like let's take some like this, and now let's start carry forwarding numbers over here. Since it's 15, we carry forward 1 over here and keep 5 here. The number 11 here, number is 11. We keep 1 over here and carry forward the remaining ones to get 6 plus 1. 7. Nothing carry forwards, so it remains 3, it remains 1. The crux of the problem is like in general, if you add two numbers, like carry forward happens only once. But if you are trying to add 10 numbers together, like your carry forward can be at 9 as well. Like for example, let's pick 987. Then 9 plus 8 plus 7 is 24. 8 and 9 sum is 17 and 9 is 9. Here you have first maintained these digits and now you carry forward 2 from here. Keep 4 here, 2 here, 19. Now you keep 19 over here, carry forward 1 again. You have got 10, keep 0 and carry forward 1 again. So overall you will get 1094. Like this was essentially the idea for this problem. I took as a string, I reverse all the strings, and like now I am maintaining like starting from the reverse, like how many times the sum so far over here is there. And like once I know the answer, now I am looking at iterating again and trying to carry forward if the current number is greater than 10. If I have reached the end of the array, I create one more tens place over there by posting 0. And then like carry forward is number divided by 10, add it to the I plus ones place, and like now take the remainder. And now the string array where I am maintaining s as a string. And at last, what we need is like we have to also remove the leading zeros. Like if we look at this problem, like here, like although number is 005, you should print 5 over here. I removed all the leading zeros, reverts, and like print was the main idea. Like, and I doubt you would be able to use like for example, Python supports adding large numbers, and even Java also supports. But if you add the number n times, you might get a TLE over there. And like this was the idea. Any questions before I move to the sixth problem? Okay, moving to the next problem then. Next problem says feed cats. There is a fun game where you need to feed cats that come and go. The total level of game consists of n steps. There are m cats. The ith cat is present from step Li to Ri inclusive. In each step, you can feed all the cats that are currently present or do nothing. Like you don't have to selectively option to selectively choose the cat. Either feed everyone which is present or do nothing. And if you feed the same cat more than once, it will be overeat and like you will immediately lose the game. So we have to feed the cat only once every cat at max. Your goal is to feed as many cats as possible without causing any cat to overeat. So like we have some set of cats, and like there are some, let's call this step as some times over there. So like you are in a room sitting with a lot of food. There are some cats which appear on some time and they go after some time. In this case, we can say that the ith cat comes into the room at Li seconds and moves out from the room at Ri seconds. And at some point, you decide to feed all the cats which are present in the room. Like you cannot say like you only want to feed these 3 cats and the 4th cat in the room will not do anything. Either you feed every cat which is present in the room or you do nothing. And like the problem is you cannot feed a cat multiple times. Like if you feed a cat 2 times, then that cat will die or something like that, and you cannot do that. And our ask is like what is the maximum number of cats we can feed after waiting in the room for n seconds overall. So like this is essentially the problem. And now if we look at the samples, like the first cat, like you wait from time to 15 seconds. The first cat appears in at t equal to 2 seconds and remains in the room until t equal to 10 seconds. The second cat comes in the room at t equal to 3 and remains in the room until 5th second. Cat 3 appears in the room at t equal to 2 and remains in the room until 4th second. Cat 4 comes in the room at 7 seconds and remains in the room until 7 second only. Cat 5 comes in the room at 8 second and remains in the room until 12 second. And cat 6 comes in the room at 11 seconds and remains in the room until 11 seconds. And the solution claims like we should feed 2 times. One at 4th second. So like all these cats would be feeded at that point of time. And the next time we should feed at 11 second. So like these two cats would be feed and the maximum you will get is 5. Similarly, you can work out the other examples. And the idea was to use DP. DPT denotes like the maximum number of cats you can feed, like if you try to take from time 1 to t. And the idea was like we decide when we will feed, but then like for example in this example, like we have feeded the cat at the 4th second, right? And after the 4th second, when we have feeded, like we cannot feed the cats again until the 10th second, because like cat 1 got food at 4th second and they cannot get food at 10th second. So my idea was when we are feeding cat t equal to 4, we look at like what is the maximum answer we can get up till 3. Third time 3. Like whenever we want to feed, we should look at like what is the maximum number of cats we have hidden until time t minus 1. Then we should also count the cats which are in room at time t. And we should also find one r, which is max time of cat which is present at t, at time t. So in our case, like if we look at the cat 4, like there are 3 cats in the room. One of them goes out at 4, them goes out at 5, one of them goes out at 10. So the maximum time of a cat which is present at t equal to 4 and will remain at room is until t equal to 10. So now instead of like if r is the max time, instead of writing dp t equal to dp t minus 1 plus cat count, instead of t let's call it r. Because once you have feeded a cat at time t, you cannot feed any cat until time r. So we simply say that like r by the time r, this would be the count of cats I would have feeded if I want to. Because once you feed at cat at time t, like there is one cat which remains in the room until r, so you cannot feed that cat again. So like this dp, instead of like the number of cats we have feeded at time t, is the number of cats we have feeded until time t and when they have also exited the room. Like the general dp idea is like dpt, number of cats you would feed until time t, but that doesn't work because some cats still remain here. So we define a new dp state where dpt is the number of cats you have feeded until time t and they have also left the room, because once you move that into the picture, like after time t, you are free to add new cats, feed new cats. And like one more idea remains, like if you decide to do nothing at time t, you can also take this as dpt minus 1. So you can take max of all the cats, and this is essentially the idea. You need two things for each time t which given in the input. You need a count of cats that are in the room, and the maximum time when a particular cat will leave which is present at time t. If you know both of them, then you would be able to define this dp recurrence. And like for the cat, like I tried to maintain a multi-set using a map. Like one starts and ends, where I am denoting like what are the starting times of a cat which leaves the room at a particular, like starting time is I, like what would be the ending times, and ends denotes like what are the cats which would be living at a particular time. For cat I look at the L and R. I put the endpoint of this cat in the vector L, and I also put for the endpoint the starting vector over here. And I am trying to use a prefix sum kind of a thing. Like what I'm saying is one extra cat enters the room at time R, and time R plus one extra cat moves out of the room. Here I am trying to maintain a multi-set into points, but there would be other ways to do it. Now I am starting from the current time. Instead of current index, read it as current time from 1 to n. The number of cats, like these current variable is the number of extra cats which are in the room, like the difference of the cats exit and enter, and like this were previously in the room. So after I maintain this, like current count index would denote like the number of cats which are in the room. Then I iterate over all the cats that can enter right now, and I add them into my current pointer. Like the left index is definitely not required. I am doing something extra over. So I am maintaining the right endpoints, like the time for all the cats which would be exiting now. First, I look at all the new cats which would enter into the room. And like I also even don't need this current count over here. And the zero cats are in the room. This denotes the state when I do nothing. Otherwise, I look at all the cats which enter right now. And if the cats count is like if there is at least one cat in the room, I look at the maximum time, which because I am maintaining in the map, I would be able to get it. The number of cats which have exited by now, which is current time minus one, and the number of cats in the room, and mark it as DPR, like the last time when the cat will exit the room. And this is essentially the code for this one. So any questions on this one before we move to the last problem of today? Like I will say like what approach I was following, but I had some bugs left and right, so I did not got anything. So moving to the last problem for today. It says moving platform. There is a game where you need to move through a labyrinth. The labyrinth consists of n platforms connected by m passages. Each platform is at some level li, an integer numbered from 0 to h minus 1. In a single step, if you are currently on platform I, you can stay on it or move to another platform j. To move to the platform j, they have to be connected by passes and their levels have to be same, namely li equal to rj. And after each second, like instead of step, let's call it a second because it's easier to talk in time. The level of all platforms changes. The new level of platform I L dash becomes Li plus Si mod H, where H and Si are given to you for all I. You start at platform 1, find the number of steps, number minimum time you need to go to platform N. Let's look at the sample ones. And it also says print -1 if it's impossible to reach platform N. And like when you model something like find the minimum time to reach somewhere, like what should strike over here, like the some shortest path finding algorithms. Like in the first sample, it says at time t equal to 1. Like let's just read, like it's also given over here. At t equal to 1, the level of platforms is 194. And because no one is at the same level, you cannot do anything. So you have to stay on the same platform. After 1 second, like the level of platform changes based on this formula. And the new level becomes 324. No one is at same level, so you should do nothing, stay at a platform 1. At time t equal to 3, like the platform 1 and 2 are at the same level right now. So you should jump from 1 to 2 then. And now at time 4, like multiple platforms change. Like no one is at same level, you can't do anything, you stay at platform 2. Then again the platform change, but no one is at same level, so you should not do anything. And now like the platform 2 and 3 comes at the same level. So you can jump from 2 to 3 and you reach the final platform. And minimum time taken is 6. One critical thing to note over here was like you can only jump one platform at a time. Like let's say if there are 3 platforms at the same level and they are indirectly connected, then in 1 second you can only jump once over here. You cannot jump 2 times. So like again, a Dijkstra is required, but a modified Dijkstra is required. Shortest path. Like if you look at this as a shortest path problem, like the only you have some edges, you have some time, but you don't know like when the levels will be at same time. And if you can somehow quickly find that, then like let's say you are at platform I and the next platforms are connected at v1, v2, v3, and you are at time t. So the best scenario in your case when you are running the extra would be you find like when these two platforms will come over here. Let's say they are at the same level t1. So when you are running the shortest path finding algorithm, you can claim that by the time t1 you would be able to reach v1 if you have reached the platform I at time t. Similarly, when you are at time t, the next time when v2 and the current time are at same level, then you can put this t2 and v2 at the same level and you can put v2 into the priority queue. Similarly, if v3 is the next neighbor, like you can look at t3. And like it can also be the case that platforms never come at the same time. In that case, that edge is useless. So I will pick one of my TLE submissions. Like I take all the starting level and the delta as input. Like let me first pick the first submission. Like I take the starting level of all the platforms as input and the jumps they would be taking. I also take current graph as input and maintain it in adjacent list. Now instead of priority queue, I am using set for the main priority queue. You can also use a priority queue. Like at time 0, you are at the platform 0 only, like the first platform 0 base index. And the distance for this is 0. Now you run a Dijkstra loop. You find the nearest time first. You erase it from the queue. You look at the node and you look at the time. You look at its current level and you iterate on all the numbers. Like when you are at time t, you also know the level of v. So you find the current level of v, and you also find the how many times you will have to wait over here, so that the levels of v and u become same. If it's impossible, which I am denoting by -1, you ignore it. It's this as is useless. Otherwise, in the Dijkstra loop, the time taken to reach v is less than equal to what if I go from u at time t to the next jump. Then I ignore this edge. Otherwise, I may have to delete this from the priority queue, and I find the new time t, like when I would be able to make a jump. I mark it over here and I push it into the queue. Like this is a Dijkstra loop for finding the shortest path. The only difference over here is like we are dynamically calculating the weight of edge based on like current what time it is, and like what are their deltas over here. And like I had bugs in this function. Like I can say like one idea which I have used to find like the next time, but it was not working for me. And because you cannot move to multiple platforms in one stop, so like if you have reached the time t, you at time t, you should have like this value should be at least 1. But at the same time, when you are at time 0, like you are at the first platform, in the first step also you can jump. So like this was one corner case. And the way I modeled it was like let's say we have reached u at time t, and we want to find like dt as the next time when its neighbor v would be at same level as the current node u. Then we can write the equation as au like let's call it delta t. Au plus the time you are taking for each move plus delta t into du should be equal to av plus dvt plus delta t dv, and everything is modulo h. Now you can move like this delta on one side and everything else on the other side. You will get au plus dut minus av minus dvt, which is equal to delta t dv minus du. And this we need a minimum delta u delta t which is greater than equal to 1, and we can take that as an adjunct. The way I tried to solve this problem was like if you look at it, this equation changes into like a equal to delta t into d mod h. Like you can make it one constant, you can make it the other constant. Now if this d is 0, then if a is 0, like the platforms are at same level always, so you can take delta t equal to 1. Otherwise if d is 0, like you will notice like the difference of the platforms never change, so like delta t equal to impossible. And there were other cases as well. Essentially what you need over here is if there exists an inverse of d with h, then you can multiply this equation by a d inverse, which would be a delta t into d inverse into h, and a d inverse would be delta t into h. Like I was trying to solve it like this, but had some bugs left and right. Or the other way can be like extended gcd. Like what we can write is like from extended gcd we know like we can write a number as au plus yb like given d and h, we can write this as we can get some coefficients x and y such that xy plus yh is equal to gcd of d comma h. Like this x and y can be negative 0 anything over here. Then because I need a over here, I can multiply this equation by a by GCD of d comma h. So if this is not a proper number, I say the answer is impossible because all the multiples over here would be of this GCD. Otherwise, this becomes x into a by GCD into d plus y into a by GCD is equal to a. And then I try to take this value like mod h. Here we have h. And like this was my idea, but I like it looks like it failed somewhere. So like the essential idea was to do Dijkstra dynamically find the edge widths, and for edge width you have to solve some equations of this form, which becomes like a is equal to some delta t into d, and like where you have to take everything over here as mod, and you have to find the minimum delta t which is positive over here. And like this part I was not able to solve, and like I looked at Turi's submission, like this is essentially he was doing, but since he is tourist he was able to correctly find delta t as well and solve everything and become first in the contest. And this ends my stream for today. If there are any questions I can take them off, otherwise I will call it a day. Thanks everyone for joining. Any resource for F type of problem, like essentially like I can't think of like any standard problem, like there may be some, but like the best way would be like to solve more DP problem, because at least if you ask me for the last problem, like I can say like if you need Dijkstra, some Dijkstra resource for Dijkstra, or some solving the diagram equation. And any resource for C type of problem, like C, I would say like first the idea was essentially realizing you cannot divide it, and like if you need something for that, like for C the idea was if you do not know modular arithmetic, like how you divide multiply by some mod, then like for C like this would be the way to go. Like you should know like how you multiply divide the numbers when it's as something modulo, and if you know these then like you would know like how to solve this problem. Like there were some other ways as well, like where because like GCD was a problem, you maintain all the prime powers of the prime factor of that m, and you try to solve this problem. One other way to solve this was to find all the prime factors of n, maintain their power separately and other numbers separately. Like I am employed right now, and like I generally, if you look at my stream, I generally do them on Saturday, Sunday most of the time. Otherwise, on weekday it's after 8 p.m. or something like that when I'm done with my day's work. So like I'm not really sure if primes get an AC or not, but yeah, like that is one alternative way to at least solve this problem. So if there are no more questions, then I will call it a day. Thanks everyone for joining today.